Hi guys, I'm hard at work on two technical videos. You can see the printers behind me on the bench, and those will be released in the next couple of days, so no more drama, we hope. But I wanted to take this opportunity to feature somebody else on this channel. I don't have a substantial audience, but it's larger than a lot of people, and I just think that this is one of those projects that kind of didn't pop up on everyone's radar, and it really should have. So a longtime friend of the channel, who goes by the name of Constantijn. He has his own little YouTube channel himself, so down in the description you can find a link to that. And you're going to want to ring the bell on his channel after you subscribe, because sometimes he goes like a year without uploading a video, which is just murder on your channel as far as the algorithm's concerned. It stops featuring you. So if you don't ring the bell, you're probably never going to see his content again. And it's just amazing content. He does everything that he does is really good. He's a German engineering student, so he's got the innovation and the attention to detail you come to expect from German engineering. Anyway, so I asked him to make this little presentation video a little bit different than what he does on his channel, just showing us the details of his transformer printer. And this thing is, I think, the most unique DIY printer design that I've ever seen. It's so cool. So without further delay, let's check it out.
Hey, I guess you were expecting someone else here, and I'm sorry about that. Matthew will be back, but he has seen some of my videos that I shared on my own YouTube channel about this 3D printer, and he asked me whether I'd like to, do a bit of a showcase on this 3D printer. And I guess that's what I'm going to do. So first of all, hi, nice to meet you. My name is Constantijn, and this is my printer. I called it the Transformer. You'll see later on why. And I built this printer, I guess something around 2 years ago, which means the hardware is quite dated on this printer, so bear with me. But what's interesting about this printer is the mechanics, and those are not dated, so maybe that's what you should concentrate on a little bit more than the rest of this printer. So I guess let's first talk about the specs of this printer. I have a normal E3D V6 hot end with a normal inductive probe, so no smart features, no temperature sensor or something like that in there. I have a Bowden drive coupled to a non-geared extruder, which is quite a pain because it does like to skip steps every now and then. Then I have linear rails all around, and the movement system looks like CoreXY, but it's intentionally not, because first of all, what I don't really like about CoreXY is that you have crazy long belt runs, and the longer the belt runs are, the more play or the more springiness you get in your belt system. Also, this printer still runs on a RAMPS 1.4 board coupled with an Arduino, so an 8-bit board. It's crazy slow, something like 16 or 18 megahertz or something like that. And the additional overhead that you need for the calculations to do CoreXY movements is so high that I didn't really want to use all my processing power just to calculate CoreXY movements. There are much more important things to be calculated other than CoreXY movements, so that's why I left it out. Of course, nowadays there are much better boards than the RAMPS 1.4 running on an Arduino Mega. But since this printer is working for me, I didn't really have any reason to upgrade. But now for the interesting part, the build volume. So the build area is 200 by 200 millimeters. Okay, nothing special about that. Basically every printer has a build volume or a build area like that. But the build height is 360 millimeters. And this printer is just about 300 millimeters high. So how is that possible? Let me show you. Okay, prepare, move axis, move Z, and let's go to 360. This will take a while, so I'll use the time to sprinkle in some more information. First of all, the most glaring observation is that the Z movement is quite slow, which leads me to the first of many downsides of this printer. Instead of moving just the build platform up and down, this printer has to move the entire XY gantry up and down, which, as you might imagine, is quite heavy and therefore affects the speed at which the gantry can move up. You'll probably also have noticed how my banana spindle is flapping around in the breeze, but do you know how hard it is to get straight spindles? I mean, take a look at some of the other ones I've ordered. I guess that particular reseller expected me to print around the corner or something. Well, there we go. I guess now it's obvious why I called this printer the Transformer. So what's going on here? Well, instead of using normal linear rails for the Z-axis, I'm using drawer slides, but the drawer slides that I chose were just normal drawer slides from Amazon, and those slides were really cheap and really bad, in the sense that they have play in basically each of the axes of the slide itself. And in order to combat that, I over-constrained the entire movement system of the Z-axis. That means that I used 2 of these drawer slides on each side of the printer. Although what I also did is I soldered the slides back to back in order to increase the height that they were able to reach. And that way I ended up using 16 slides in total. Now let me show you what's under the hood. And as you can see, it's not much. So first of all, power comes in here, goes into the power supply, which is nothing special. Let's see, it's a 360 watt power supply, 12 volts. So yes, this printer is indeed running on 12 volts, which is definitely not optimal. But back in the day, this was normal. This was how printers were built, and that's why I built it the same way. You know, in order to use a ramps board together with a 24 volt power supply, you would have to modify the ramps board. Those 24 volt power supplies were kind of hard to get. And 24 volts and 120 or 240 volt heated beds were also not really a thing yet. Of course you could buy them, but they were meant for industrial use or something like that. And that meant that those were extremely expensive. And because this still runs on 12 volts, of course you need very heavy gauge wires. I use a MOSFET for the heated bed, an external one. Then of course I have the ramps board, which is, for all of you who don't know, just an add-on board for Arduino Mega. So this is actually running on an Arduino Mega, which is just crazy to me. I mean, nowadays no one really does that anymore, but it's just crazy. It's kind of cool. I really like it. For the drivers, I'm using TMC 2100 in standalone mode, although of course TMC 2100s only have the standalone mode, so that's no big surprise. And I had some issues with the drivers overheating, so that's why I added this fan, and later on I added this fan as well, which is just propped up on a piece of test cube. But it works, so that's fine. And this cable here is to control my DSLR camera to do those stop motion videos. Because also, back in the day, Octoprint didn't have the plugin yet, so if you wanted to make those stop motion videos, you would have had to control the camera just straight via G-code. And in order to not fry the camera itself, I just have an octocoupler in here, which decouples the camera from the board itself. I think now's a good time to finally print something, and I can't think of any better way than to print a Benchy. Haha. No, but for real, I'm actually going to print a Benchy. This will again take a while, so let's just chat some more. One thing that I get asked a lot is why? Why go through the effort to make a printer like that when there are other mechanically superior designs out there? And that's actually an easy one to answer. I just thought it might be cool and I liked the design challenge. My first idea was to make a scissor mechanism to lift the XY gantry, but I quickly realized that I would introduce potential play in every joint of that mechanism, which would add up the more joints I added. So instead I unfortunately had to go with those ugly vertical spindles. But speaking of the spindles, I made a mistake with the layout of the spindles by attaching the spindles to the center of the XY gantry. Back then that made a lot of sense to me, but unfortunately that results in the gantry not being pre-tensioned correctly. With the spindles mounted like that, they create a pivot axis around which the gantry can tilt back and forth. This doesn't happen often, but when it does, you'll get a layered effect in your print, which doesn't really look super nice. The better way to mount the spindles would have been to use a cantilever design, which would automatically pretension the XY gantry by gravity. By the way, these loose cables are still unsleeved because I recently made some changes to the gantry and I thought that I would still experiment with it, which of course I never did. Before, the XY gantry used the same mechanics that are found in Ultimaker printers, and I ended up switching because you need bushings instead of bearings for that design, since some of the rods both work as linear guides as well as to transfer torque. The bushings that I had were starting to wear out, so I just ended up changing it for what you're seeing right now. Okay, that print was too small to see the gantry move past the mainframe, so here's a clip I filmed for my own YouTube channel where I used the entire build volume to print a vase, which I think is one of my favorite clips I filmed so far. I used a 0.6mm nozzle with a 0.4mm layer height as far as I remember, so the layering is pretty rough, but for some prints I really like that kind of aesthetic. So let me know if you like the showcase, because I do have some other printers that I could talk about, which maybe are even more interesting than this printer. They are still in the works, they are still being built, but even that could be interesting. And in case I forgot to say something about this printer, I have an entire playlist about it on my YouTube channel, which is quite cringy, but the information is there. I also have it posted on Thingiverse, and of course I'll be in the comments below answering all the questions about it. And at last, of course, I want to give a big thank you to Matthew for giving me the opportunity to talk about this printer on his channel. And I hope to see you very soon in maybe the next video on this channel or on my channel. Goodbye.